Hey guys, this video is for honors who are starting 2.3 rates and unit rates. This will be hopefully the entire video. I've been having some issues while recording. My phone keeps saying I'm out of storage, so I'm hoping that this will work. If not, this will be split up into two different videos. So go ahead and get these notes out in front of you, and we're going to start talking about rates and unit rates. Okay, remember that we are in the chapter discussing ratios, and with that we can also kind of use a ratio to describe something called a rate and a unit rate. So let's look at this key idea here. It says that a rate is a ratio of two quantities using different units. Okay, different units just means two different kinds of measurements and things. Okay, so what we've got here could be maybe we're comparing 2 cups of something to 2 quarts of something else, or 2 cups of something to 1 gallon of something else. Okay, those are the comparisons that's using different units. So we're not comparing cups to cups or inches to inches or miles to miles, something like that. They're two different units. Okay. But a unit rate compares a quantity to 1 unit of another, okay? So this is like saying, 16 cups to 1 gallon, or, 30 miles per 1 hour or something like that. That's just comparing some amount to one of another, okay? Equivalent rates will have the same exact unit rate. So we'll get into all of these definitions while we are working through the next few problems. Now this is a really quick lesson. There's not a whole lot going on here. And then what you'll be doing on the next page is kind of practicing some rates and unit rates and doing some comparisons, okay? So let's take a look at it. What we have here in the first example is you pay $350 for every 1/4 ounce of gold. This is kind of just a visual representation of what that looks like. 350 to 1/4, 350 to 1/4, 350 to 1/4, and 350 to 1/4. Now what they're doing here is showing you the difference between a rate and a unit rate. So the rate, the initial rate, is $350 to 1/4 of an ounce of gold. Okay, but the unit rate, neither of these is 1, so they need to compare that, okay, by either comparing how many ounces you would get for $1 or how much it would cost you for 1 ounce. Do you see how it has to be a comparison of something to one of another? So that unit rate here, it shows you that if we continue adding a fourth until we get to a whole amount, 1/4 plus 1/4 plus 1/4 plus another 1/4 gives us 4/4, right? Which is the same as 1. They're telling us that that's the same as adding another 350, another 350, another 350. So the unit rate is $1,400 for 1 ounce of gold, okay? So that's all these are describing, just showing you kind of a visual representation of the rate versus the unit rate, okay? Things to remember here in the algebra is how it might be written, okay? So you might see the rate as A to B, and then the unit rate is maybe A over B to 1, okay? And that just means we're taking that ratio and dividing it to get that per 1 amount, okay? So we're gonna practice that right now in example number 1. So take a look. What we have here is finding a unit rate. I hope that this isn't too blurry for you guys. Like I'm trying to keep it from glaring. Okay, a nutrition label shows that every 1/4 cup of tuna has 1/2 gram of fat. So we see here our rate, okay, a ratio of two quantities using two different units, okay? Our ratio is 1/4 to 1/2, okay? We're comparing cups of tuna to grams of fat, so cups to grams, all right? And then we need to figure out how many grams of fat are there for every 1 cup of tuna, okay? How many grams of fat are there for every 1 cup of tuna. So we need to figure out how in the world are we going to do that. Well, the first thing that we need is the ratio in the very specific order that it gave us, okay? So remember that when we write a ratio, we pay attention to the term. So it's asking us how many grams of fat for every cup of tuna. So let's go ahead and write it, grams of fat to tuna. Now this one up here was opposite that, okay? So this one is going to be grams of fat is 1/2 and cups of tuna is 1/4, okay? Here's our ratio. Now to find the unit rate, take a look back over here. To find the unit rate, this is what we need to do. A over B will give us our amount per 1. So we need to take that first amount and divide it, remember a fraction means division, by the second amount to get our per 1, okay? And what we're looking for is something per 1 cup of tuna. How many grams for 1 cup of tuna? All right, right now what we know is that there's 1/2 of a gram for 1/4 of a cup. So maybe you could try to do that math already in your head, but if not, what we're going to do is divide. So I'm gonna write that down here, 1/2 divided by 1/4. Now we've been practicing this over the last several lessons. How do I divide fractions? You should remember we're no longer using our elementary terms. It's not keep, change, flip anymore. Now we multiply by the reciprocal. Okay, multiply by the reciprocal. This becomes 1/2 times 1/4. When you're multiplying now, you multiply straight across. So this answer becomes 1/8. Okay. Okay, so our answer is 1/8 grams of fat per 1 cup of tuna. Sorry, I know that's going off the page. Okay, but this is what the question is asking us. How many grams of fat are there for every 1 cup of tuna? Okay, and that's what we just figured out here. So 1/8. All right. There is a way to kind of show this visually. You could do that, but it will show us that in this second option here, this part B. So let's take a look at part B. Now part B says how many cups of tuna would there be or are there for every gram of fat, okay? So now what we need is to write this ratio, okay? Remember at the top of the question, we're looking for tuna first because that's what comes first in the question, and then grams of fat, okay? So the amount of tuna here is 1/4 of a cup. So we're writing this as 1/4 to grams of fat is 1/2. So 1/4 to 1/2. Notice that this ratio is different and we are going to get a different answer. So this is why it's so important that you pay attention to these things, because you will get different unit rates as you go through and solve this, okay? All right, so let's take a look here. How many cups of tuna are there for every 1/2 of a gram of fat? Okay, let's divide them. Sorry, this is what we need to do. We need to divide the first by the second, and that will give us our answer. Okay, 1/4 divided by 1/2. Sorry, let's divide. 1/4 divided by 1/2 is the same as multiplying by that reciprocal, which is 1/4 times 2/1, sorry. And that gives me 2/4 or 1/2. Okay, so the answer is 1/2 cups of tuna per 1 gram of fat. So here is how we take our ratio as a rate and turn it into a unit rate, okay? So here is the rate, 1/4 to 1/2, but as a unit rate, this now becomes 1/2 of a cup of tuna per 1 gram of fat. A unit rate compares some quantity of one thing to one of another, and that's how we just figured that out. Okay, so now there's an example here for you to try it. We've got 1/4 of a gram of fat for every 1/3 tablespoon of powdered peanut butter. So if you're someone that maybe likes to make what are those, like protein shakes or something like that, or smoothies, you might be adding some powdered peanut butter into that. And anyway, so this could be some useful information for you if you're trying to figure out how much fat is in what you are using, okay? So we need to read the question and see what it's asking us. There is 1/4 of a gram of fat for every, remember that this is another way of writing a ratio. 1/4 to 1/3 tablespoon of powdered peanut butter. How many grams of fat are there for every tablespoon of the powder? So what I want you to do here is I want you to pause and I want you to try this on your own, okay? Pay attention to the wording. Write your ratio first, okay? Write your ratio first and then divide. So pause, please, and then try it. Okay, so here we go. There is 1/4 of a gram of fat for, sorry, not 1/4, 3/4 of a gram of fat for every 1 tablespoon of powder. So you need 1/4 to 1/3 because that's what it's asking for. The fat compared to the tablespoons, or sorry, the grams of fat to the tablespoons. Okay, that's what comes first, fat, and then the peanut butter powder. So we divide those to find the unit rate, okay? And when we do that, we find out that the answer is 3/4. There are 3/4 grams of fat for every 1 tablespoon of powder, okay? Next thing, using a rate or a unit rate to solve a rate problem. I would say as we are going through this lesson, if you do have any questions, obviously you can't ask me anything. So maybe write it down next to whatever box you might have had the question. And then once you see me, then you can ask the question and we can go over it, okay? So example 2, using a unit rate to solve a rate problem. A scientist estimates that a jet of liquid iron in the Earth's core travels 9 feet every half hour. How far does the liquid travel in a day? Okay, and then it says to use a ratio table to help you find the unit rate. So just like we did before, okay, in the last lesson, we can use that table and continuously add over and over until we get where we need to be, right? Our very first amount that we have is the feet or the distance. We know that we're going 9 feet every half hour, okay? And then if I added another 9 feet and another half hour, I would be at 18 feet per 1 hour. Okay, but the issue states here that the question, is asking me how far does a liquid iron travel in 1 day, okay? Right now what we're talking about is hours, right? So how do I get from hours to a full day? Okay, well, I know that in a full day, I have 24 hours, right? So in between here, I've got to repeatedly add over and over and over until I get to 24. But we talked about this the other day, that I don't have to actually do that repeated addition over and over and over. What I can do is multiply. Okay, so that's what I'm going to do. I'm going to skip all of this adding 2, 3, 4, 5, 6, 7, blah, 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 and I'm just going to skip it. I'm going to go right to it. I know that from 1 hour to 24 hours in a day, I would multiply by 24. So then I would take this distance and I would also do the same thing, multiply by 24, okay? So let's do that, 18 times 24. And let's figure out what that answer is. Go ahead and pause the video and see what you get and then compare it to what I get, okay? You can tell me if I'm right or wrong. All right. Okay, if my math is right, then the answer here is 432. Let's see. Okay, but what does 432 mean? Remember the question? Let's look back at the question. It says, how far does the liquid iron travel in 1 day? We're talking about a distance here in the table in feet. Okay, so that means that after repeatedly moving 9 feet in an hour, or sorry, 18 feet in an hour, then I would get to 432 feet in 24 hours. So the liquid travels 432 feet in 1 day. Okay, here's my unit rate because now I'm comparing it to 1 day instead of 24 hours. Okay, do you see how that changes there? Okay, we take that 24 hours. We know that it's 24 hours in a day, but I need it to be an amount compared to one of another. Okay, so this is the unit rate. Remember, the question is using a unit rate to solve a rate problem. So here's my rate problem. Here is my unit rate answer. Okay, do me a favor and turn the page. That's kind of it for this lesson as far as the book goes. But what you will see on the next page is an assignment asking you to find a bunch of unit rates, okay? And this is where this would apply most often in real life, okay? You're going to spend the remainder of class working on this page with just your table groups, whoever is sitting near you, so you don't need to get up and move around the room, but you're going to answer all of these questions. So let's read these instructions together, okay? Let's go to the movies, find the better buy, okay? So what we're doing here is we're going to compare things that are happening at 2 different movie theaters, and then we're going to decide which one should we go to based on the prices of things. And the same thing would happen to you or to anyone if we were going grocery shopping. Maybe we're trying to find an item and one brand sells it for $10 and another brand only sells it for $7.50. Well, obviously we want to go for the better buy. Now, sometimes we like buying things that are more expensive. Maybe in our minds it's better quality or it's a better taste or a better something, so we're willing to spend the money. But other times, when we're going to the movies, we get to watch the movie no matter what, right? So maybe we won't necessarily care about the quality of something that we're getting because it seems to be about the same. Okay, so let's read these instructions. I'm sorry if it's hard to read from here, but you should have this in your notes packet. So you and some friends are headed to the movies. The movie you want to see is showing at 2 different theaters. You want to save as much money as possible by finding the better buy. We can do this by finding the unit rate. The per one, okay, the amount of one thing compared to one of another, okay? Show your work in the box and round your answer to the nearest thousandth. Okay, this is really important for some of these questions. And write the name of the theater that has the best value. So when you are finished, determine which theater you should kind of go to. It says calculate the total cost of your movie ticket and 3 snack items. So this will be up to you. Kind of once you go through all of these items, there is a front and a back side. Okay, so there's 3 other items on the back side that you'll get to choose from. But I'm going to show you what is going on in the first one. So we're given a rate. I want you to write that next to each of these. Okay, this is the rate because the rate is just a ratio of one thing to another, and it tells us that we're paying $47.95 for 5 tickets. Okay, the other theater, the Bellevue Cinema, is $40.96 for 4 tickets. So we want to figure out what is the unit rate. The unit rate is asking us the cost for 1 ticket. Okay, that's what we need to figure out. So to do that, I'm going to take my first amount, okay, the cost, and divide it by the quantity of whatever it is I'm purchasing. So in this case, it's the tickets. I need to do $47.95 divided by the 5 tickets. This is going to get me my unit rate, okay? It's the first one divided by the second one. Same thing in the next one. First one divided by the second one. So what you see here in my work is that I've gone through, on the second one, I kind of worked all the way through, but $47.95 divided by 5 in the first one is $9.59. And I can do that math with you here. Okay, I'm asking myself, how many times can 5 go into 4? Well, it can't. So what about 47? Okay, it can go into 47, and the answer is 9 times. Okay, 5 times 9 is 45. That leaves me with 2. Okay, 5 can't go into 2, so now I've got a decimal, and I bring down the 9. Okay, 5 can go into 29 5 times. That's 25, and I'm left with 4. 5 can't go into 4, so I bring down that 5. It can go into 45 9 times, and this is where my 9.59 came from. Okay, so the unit rate, the per 1 ticket, is $9.59. Okay, then we do the same thing over here. We're given a rate, $40.96 for 4 tickets. I need to divide those two, so $40.96 divided by 4. And once I work all of that out, I get $10.24 for 1 ticket. Okay, remember a unit rate is for 1 per 1 ticket. Okay, I hope that makes sense. So then off to the side, it says which theater is the better buy. Well, in this case, we're only paying $9.59 for a ticket at the Emerald Theater versus $10.24 for a ticket at the Bellevue Cinema. Okay, so the Emerald Theater is the better buy. And now what you'll do is you'll go on to the popcorn. Okay, now you're looking at popcorn for both theaters. So $7.10 for 10 cups versus $9.05 for 16 cups. And then you have to show your work for each of these. So show me that you're dividing them out. Okay, divide those two and tell me what the answer is. The unit rate that we're looking for in this case is what is the cost per 1 cup of popcorn, okay, per 1 cup. So go ahead and work with your table groups on this once they're finished up with everything, and then answer this to the best of your ability. I want you to try to finish whatever you can in the amount of time that you have left in class, which probably isn't very long, maybe 10 or 15 minutes. This is not homework, okay? We will finish this in class on Friday, and then we will move on to the 2.3 homework Friday, okay? So you'll do that, and you should still be working on your project. Remember that the project is due tomorrow for bonus points, okay? So good luck with all of that. Email me if you have any questions, and I will see you soon, okay?